Today's lab is going to just focus on what we covered in Chapter 17, the common minerals. That's right, we're not going to go to the big island of Hawaii and walk on a volcano or try to see some of the tectonic plates move out in California. But this should be, the minerals are very interesting, and I've associated with this is another download that you have. There is a picture of the different minerals. And I've assembled the ones that are listed on the table for this lab. And so you have a visual representation of what these different ones look like. But so what we're going to be doing is, while there are many, many different minerals, there are only a certain much smaller number, like we will have today in our lab, that are actually that are common in the Earth's crust. But what this means, though, is that it's possible, and the ones that I will, I have to do a little caveat here. The ones that I'm presenting to you, these are some of the best pictures of just that one mineral by itself. It does not have, many times the rocks are going to have a combination of these different ones together. Okay, so, but these are good examples, and they will allow you to get an idea about them. What we're going to do, the purpose of this lab, or what we're going to be doing, is developing a table. Okay, that table is back here, and what we're going to do is go through all 19 of those different minerals, and we'll be looking at them in terms of color, luster, streak, and then we're going to continue on to the next page. And you'll see that this starts off with calcite again. And now we're looking at the properties of hardness, cleavage, and then other. Okay? And so what you will be doing is I'll be describing them, and you will be filling out this particular table. And while at the same time you are looking at the rocks that we have right here, these minerals that we have right here. Okay? So and the properties, there's a series of different properties that we're going to be looking at. The first is color, which is just an obvious one. What does it look like? And it's not as useful as some other things because it's possible for there to be a lot of impurities or things on the surface. The streak is when you take that rock and put it in a very fine powder. And usually it's more consistent then at that particular one. And you observe this by rubbing the corner of a specimen across an unglazed streak plate. So there's a very specific plate that geologists use in order to determine this test. And I'll give you the specific values for that. Then we'll also talk about hardness using the Mohs scale here. And then we'll talk about the cleavage, and it's some minerals tend to break along smooth planes, and so we'll talk about those. And sometimes it cleaves, it's perfect. Other minerals, it's indistinct, or other things. The fracture, those that do not have cleavage may show fracture of some sort. Okay, and so it's a irregular, broken surface rather than a smooth plane. And there's also something called conchoidal fracture, and this is breaking down along the curved surface, and a few of the ones that we have today will be doing that as well. These two properties will be in a single column. Luster has to do with the way in which a mineral reflects light. Minerals that have a surface sheen are described as metallic, non-metallic, glassy, pearl. Opalescent or pearly is something that is oftentimes used as well. Vitreous, like glass, that's what that one means. Glossy, dull, and so forth. We are not going to be talking about the density here, but we will be talking about other properties. Okay, so let's get started on these. The first of them, while I could have given, I'm sure you have unknown rocks out in your backyard you could take a look at and see if you can classify them according to this. But that's not a part of this lab. We're going to be going back and forth between these two different tables. We're talking first about calcite. Okay, calcite is this material right here. And in terms of color, they look at that as a light pink color. Okay, a light pink color. And it's sort of vitreous. It's kind of a dull. And when you look at a streak of this, it is actually white. Okay. In terms of the other properties, the hardness of calcite, this is on your next table. The hardness of calcite is a 3. And the cleavage or fracture pattern, when you break this up, it's rhombohedral, okay? RHOMBOHRAL, okay? And other characteristics, it's a very brittle. So other, you'd list brittle. Okay, let's go to the next one. This one is magnetite, right? And as you could expect from a name like magnetite, it's got a lot of iron in it, and it's very magnetic. The color of this is actually black, okay? The luster is metallic. You can see there's a high sheen on some of these surfaces. There are some examples of this where it looks like a belt buckle of some sort. And the streak, of course, is black as well. The hardness factor for magnetite is a 6. When you try to cleave it, it will be rather indistinct. So cleavage or fracture is indistinct. And one of the other properties of this, of course, is magnetic. It is magnetic. This next one is pyrite. Okay, I mentioned this earlier during the lecture. And this is a brass yellow type of color. The luster is somewhat metallic. It reflects light quite well. And a sort of greenish black yellow streak going for it. And it has a hardness of 6. It has a cubic type structure. And the interesting thing about this, as we know, is that it's known as fool's gold. Okay, so this also has iron in it. This is iron sulfide. Then we have hematite. Hematite is also one of the iron ones. And it's sort of a black, red-black type of color. And it's a metallic, and it's more dull than this magnetite up here. And it's reddish in origin. And its streak is reddish, I'm sure. It's reddish. And the hardness of this one is also 6. And you don't cleave this one. As a matter of fact, a lot of times where you will see this is it's kind of a smooth surface because it's come out of a volcano. And this is they call this red soil for the hematite. I don't know why they call it that. Okay, the next ones down are the first one is limonite. Limonite is a variety of different colors. It's black, brown, black type of thing with sort of a yellowish things thrown in there. And it is very dull. It is not, does not have a luster at all. And when you actually break this down into the little particles, it is yellowish brown. Okay, yellowish brown. It only looks more brownish and blackish when you have high concentration, when it's in a big lump. This right here is down to a hardness of 5, and there's no cleavage pattern associated with this. And this is a yellow-brown soil type of name for this one, or other characteristics for this other yellow-brown soil. Okay, let's go on to quartz. The quartz you'll see is on the easiest parts of it are to see inside this one quartz rock, right? Many times when a quartz rock will have these very, very precise, almost gemstone quality to them inside here. It is white and pink in color. It is vitreous in terms of its luster. And when you grind it up, it will just be white, as you would expect from something that is essentially just silicon dioxide. The hardness of quartz is a 7, so it's way up there in terms of hardness. It's if you try to break it, it's rather indistinct, or sometimes what happens is it has that sort of conchoidal type of structure to it, where it peel off in a shell. And this is often these are transparent. Okay, when you break these open and look through the individual portions of them. Now we'll go on to the fluorite and the apatite. The fluorite is a violet or a pinkish color, and it is vitreous as well in terms of its luster. It is, when you break it all down, the streak of fluorite is white. The hardness is only a 4, but it breaks off in very specific octahedral type of structure when you try to break it. The apatite, I'm sorry, and this is quite brittle. This is a brittle rock, so it's hard, but it's brittle. The apatite varies in color. This right here is one of the nicer versions of it, but there's quite a variety of those. And this vitreous, and actually is kind of a greasy feel to it. It's white when you grind it all down. Its hardness is 5. It has imperfect breakage or fracture patterns. Sometimes you can see little lines along here where it breaks along those as if it's going along a conchoidal seam. And this is acid soluble. So if you put this in hydrochloric acid, which is one of the tests that they recommended, you could get that to dissolve. Okay. Now let's continue on to the next page. And here we have, starting off with feldspar. This is a violet or pink color as well. It's vitreous in terms of its luster. When you grind it down, it turns out to be another white powder. So its streak is white. In terms of hardness, it's up at a 6. And it has, you can see that it has different lines along here, and it will break along those. It's called a basal, B-A-S-A-L type of cleavage or fracture, and it is a very brittle. Anytime you have long lines like this, it will break off along those lines. So it is a brittle one as well. Talc now is kind of a whitish or greenish type of material for its color. And the luster is very pearly, very pearly. And the powder is white, and it has the hardness of 1. You rub on this, and you're just going to get some powder off of it, right? This is the lowest of them all. In terms of patterns, if you wanted to look at this, you can see that there's almost looks like there's layers there as how it's been compressed. So this is called either uneven or basal, B-A-S-A-L, in terms of the cleavage. And it has a very soapy feel to it. The next one is hornblende, and this is black or green black on here in terms of color. It also is vitreous, and when you grind it down, it's sort of a gray or a gray-green. The hardness of this is a 5.5, and it will break off in a prismatic shape. So the cleavage there is prismatic, and it also is brittle. Finally, we come to halite, right? Now, halite is a white in color, as you would expect. That's your common table salt, right? This is not, you could actually blow up one of your crystals of table salt, and it would look like this. This right here just happens to be a large one, where each one of these you'd have to grind it up quite a bit to get these. It is vitreous in terms of luster, and when you grind it